Hello all. Today we will do the second video in our cloud platform series. Okay. So in the in the first video, we have discussed about the Google BigQuery. Okay. So here we have seen what is BigQuery and what are the different ways to extract data. Okay. And we see about the BigQuery in detail. Now in this video, we will see the what are the services provided by the Google Cloud Platform, and in that we will see the GCP storage services, that is GCP bucket and other services, and what are the deployment methods on GCP. In this, there are several methods like Google Compute Engine, Kubernetes Engine, Google App Engine, Cloud Function. And after seeing all these, we will see which deployment method should we choose. Then we will create compute engine instance. Okay, so we will create one virtual machine. Due to billing, I will delete that. Then we will see the machine learning and AI on the GCP. In that, what is Auto ML and Cloud AI platform. Then we will see the very important topic, that is Vertex AI. Because in Vertex AI we can deploy our models. Okay, and there are many other things which we can do on Vertex AI. And later in the series, we are going to extensively work on Vertex AI. So let's start first introduction. So Google Cloud Platform is a medium with the help of which people can easily access the cloud system, okay, and other computing services which are developed by Google. Uh, so this is clear. Google Cloud Platform is a set of computing, networking, storage, big data, machine learning, and management services, which is provided by Google, that runs on the same cloud infrastructure that Google uses internally for its end-to-end products. What is Google Cloud Platform? It is the set of computing or networking, storage, big data, and machine learning services, which is provided by Google, and these services are used by Google itself for its applications like Gmail and others. What are the various services provided by the GCP? So it is like networking, storage and database, developer tools, compute, big data, and IO, identity and security, cloud AI, and other many so. Okay, GCP first came online in 2008 with the launch of product called App Engine. So in 2008, Google has launched the product that is App Engine. In April 2008, Google announced a preview release of App Engine, a developer tool that allowed customers to run their web applications on Google infrastructure. So what is App Engine? It is a developer tool that allowed customers to run their web applications on Google infrastructure. Like we can run our web applications on the infrastructure of Google. Then services provided by the Google in compute, we have these services. Okay, and in networking we have this. In storage and database we have cloud storage, cloud bigtable, cloud data storage, cloud SQL, and persistent text. Yes, okay. And in big data we have BigQuery, which we have seen in our last video. And in machine learning, we have cloud machine learning, Vision API, speech API, natural language API, translation API, and jobs API. Then this is the GCP storage services. what are the storage services provided by the Google Cloud Platform. So in this, we have object, then relational, non-relational, and warehouse. So these are the table which showing Google Storage is good for binary or object data such as image, media serving backup. And then we have Cloud SQL, which is good for web framework, CMS, e-commerce. Then we have Cloud Spanner, like it is good for RDBMS. Okay. Then we have Cloud Firestone. This is for non-relational database. And then we have Cloud Bigtable. And here is the BigQuery, which comes under warehouse, enterprise data warehouse. Okay. Now we see in details about Google Cloud Storage. Uh, so Google Cloud Storage allows worldwide storage and retrieval of any amount of data at any time. Okay, so we can store worldwide and retrieve any amount of data at any time. We can use cloud storage for services like serving website content and storing data for archival and backup, or providing large data objects to multiple users. So this, if we have large data, we can store that in Google Cloud Storage and provide access to multiple users for that data. Google Cloud Storage offers direct access to Google's scalable storage and networking is infrastructure as a powerful authentication and data sharing mechanism. So it is like scalable storage. So how if our data is more, we can increase the storage. It let us store files of any size and manage access to your data or an individual or group access. So it can store file of any size and we can manage to whom we want to give the access or not. So data storage in Google Cloud Storage can be designated as public or private. We can mention that our data is public or private. Public data can be shared with anyone, enabling us to use Google Cloud Storage as a conduit to making selected parts of our data available outside your company. So if you want that any particular data should be available outside of your work is means company, then you can make it public. Okay. How to store data? How to store data in Google Cloud Storage? So how we can store data? We can upload and download file using the following methods. Using cloud storage GUI. Okay, so we can have one GUI. Then command line interface using GS util tool. Okay, so this is one tool that GS util. By using that tool on the command line interface, we can uh, store data. Then Google Cloud Storage and REST API. Google Cloud Storage also provide REST API. We can use that also. Now, Google Cloud Storage bucket. So basically, this Google Cloud Storage, uh, what are these Google Cloud Storage? Google Cloud Storage buckets are flexible and scalable cloud containers designed to store our data from any source or application, regardless of format or size. So these cloud storage buckets are flexible and scalable, and these acts like container which are designed to store our data from any source and application, regardless of format or size. In our new project, navigate to cloud storage and buckets. As we are creating new buckets, simply click on create. So here they have explained the method how you can uh, create a bucket. Okay, so this is the way by which you can create the bucket. So means we can do one thing. We can also create one bucket and then we can learn from that. So for that, so this is our third project. Let's switch to second project basically. Okay, so now we have switched to second project. And then when we click on this navigation window, you can see that different options are available. So this is related to billing. This is IM and admin. So if you want to do admin things, you can go here. Okay. And then this is marketplace. And it here we have APIs and services. Uh, So this is that, and here we have agent platform. So Vertex AI is now renamed by Google, and now it is known as agent platforms. Okay, so we will see it later. Then we have compute engine. In compute engine, we can create virtual instances, that is virtual machine, and there we can deploy our code. Then we have Kubernetes engine. Then we have cloud storage. Okay, Google Cloud Storage. This is what we are going to use. So in this we have buckets. So if I click on this buckets, so there are uh, already there are three buckets. So for now I will create one bucket and then we will create this. So for creating any bucket, we need to go here. We need to click on this create. Just a second. Okay. So now, okay. So now we will create one bucket. So for creating a bucket, we will click on this create. Okay. So now, first of all, uh, when we create on this bucket, so here we need to choose a globally unique name for our bucket. Try to create a unique name for your bucket to avoid discrepancies or ambiguity. Okay, so like we can mention demo bucket uh, 27. Okay, uh, okay. Then after naming the bucket, we will click on this continue. So here it is saying use only lowercase letters. So we will then now we will create a continue. Now we need to next step is choosing storage location. Uh, So GCP provide multiple options for a geographic location placement of your data. So where you want to store your data. Here we will choose region with a location as user central one. So here what we will choose region, and then in this region we will see multiple like northeast, North America, northeast one, North America, South America, US Central one, Iowa. So we will use US Central one, Iowa here. Okay. Uh, then we will click on continue. Now uh, you can see we need to choose how to store your data. A storage class set cost for storage. So on the basis of how we want to store our data, we will be charged. Okay, as such, Google Cloud Storage defines four bucket type that we can choose from. One is standard, then we have nearline, cold line, and archive. So standard is best for short-term storage and frequently accessed data. And near, like if we want to access our data very frequently, then we have backup and data access less than once a month. Okay, so here frequency of access is less than once a month. Okay, then we have cold line. This is best for disaster recovery. Data access less than once a quarter. So if we are in 3 months, like we are accessing our data once, then we have archive. This is best for long-term digital preservation of data accessed less than once a year. If we are accessing our data once a year, then this is the best. So it is based on the frequency. So you can see that standard has highest cost, that is 0.20 per month per GB per month. Then Nearline has $0.10. It has 0.04 and it has 0.0012 GB per month. So it is based on the frequency we are accessing our data. Now, uh, after this, uh, so now after this, we have here it is like optimized storage for data intensive workloads. So here it is asking for enabling hierarchical namespace for this bucket. So what is this basically optimized for AI/ML and analytics with a file system like hierarchical structure. This permanent option enables automatic folder names, faster folder listing, and other enhancement not available in cloud storage standard buckets that uses flat namespace. So we will not use this for this time. Just continue. So now choose how to store your data. So default storage class is standard. Hierarchical namespace is disabled, and rapid cache is disabled. Now it is asking preventing public access. Enforce public access prevention on this bucket. So that is there. Then we have access control. It is uniform. Ensure uniform access to all objects in the bucket by using only bucket level permissions. So it has uniform access to all objects of bucket. Okay, this option became permanent after 90 days. Fine-grained. Specify access to individual objects by using object level permissions. So if like we are giving any access, so it will be applicable to all the objects of that bucket. But in fine grain, we can we can specify that these are like two files there. So we want to give access to one file and don't want to give access to another file. So this is that. Okay. So continue. So data protection is there. Soft delete policy. When enabled, this bucket and its object will be kept for a specified period after you are deleted. Uh, After they are deleted and can be restored during this time using default retention duration. So this is the default retention duration means all buckets have a 7 days of delete duration by default. And if we want to change, we can customize. Okay. Then object version or version control. Okay. Then it has retention. So these are the things we are not interested too much. And then we will create. So it will be one pop-up will come. So this is just like public access will be prevented. This bucket is set to prevent exposure of its data on public internet. Keep this setting enabled unless you have a use case that requires public access, such as a static website hosting. You can change it now or later. So enforce public access prevention on this bucket. Okay, so we will just click on confirm and it will be our bucket will be created. So this is our bucket. So you can see this is our bucket and here like location is US Central 1 Iowa, storage class is standard, public access not public, protection is soft delete. Okay, so here we have different options. So if we want to create folder, we can create folder also. We can create folder also here. And if we want to upload any file, then we can upload file, we can upload folder, transfer data. If we want to transfer data in, so we can transfer data here also. So create we can create a transfer job. So to optimize this form for your transfer needs, select the type of source and destination you will be using for this transfer job. Okay, so we need to mention the source and destination. So here it is the Google Cloud Storage. We can take from Amazon S3, Azure Blob Storage or Data Lake Storage Gen 2 from URL list, Hadoop Distributed File System, and one or two more options are also there. Okay, so like this we can do. And here we have destination. Tran Now scheduling mode is batch or event driven. Transfer data accumulated at your source on a one time or recurring basis. So we can mention like after every 1 hour data should be transferred. And it is like event driven. Transfer data whenever it is added or changed at your source. Okay. So if there is any change at our source, then it transfer will happen. Uh, then choose destination, choose run when to run job, and choose settings. These are the different things. For now, we are not creating any transfer job, so we will not create it. Okay. So like this, we can do transfer. Other services are there. Explore data to PubSub. Okay, and process data by a cloud run function and inspect the sensitive data. Then we have configuration. In this, when this bucket is created, when it is updated, hierarchical namespace not enabled, location type region, cross bucket replication not enabled. Okay, storage class standard and like cloud console URL and cloud storage URI. Okay, so this is the URI of this bucket. Uh, uh, when we will be creating the Qflow pipeline, at that time we will use bucket for for storing our artifacts. Okay, so that time I will explain you, and during uh, creating the monitoring job for our deployed models like drift, we need to check the drifting, like data drift is there of parameters attribute drift is there, so we will use that time. Okay, and then soft deletion policy, all the details are there. Then we have permission, public access is not public, and access control is uniform. It protection, life cycle observability, and what is means here we can observe. Okay, then inventory report. So these are all the things we can do. This so if any running operation is there, operations running on a bucket may be initiated by other users or automated systems. Completed operations will be shown for several days after they finish. So for now no operation is here, so it is not showing. So this is how we create bucket here, and here we can store our data. Okay, so let's come back to our Rishi notebook. So, as such, Google Cloud Storage defines four types of types that we can store from: standard, archive, nearline, and code line. Here we will go with the default standard storage class. Okay. What is standard storage? Standard storage is best for data that is frequently accessed, that is hot data, and or stored for only brief periods of time. Nearline storage is a low-cost, highly durable storage service for storing infrequently accessed data. Nearline storage is ideal for data you plan to read or modify on an average once per month or less. Then Coldline is a very low cost, highly durable storage service for storing infrequently accessed data. Coldline storage is ideal for data you plan to read or modify at most once a quarter. For example, cold data storage, archive data, such as data storage for legal such as data storage for legal or regulatory reasons, can be stored at a low cost as archive storage. Uh, okay, so and this is disaster recovery, this archive storage. Now, this next step is to access of object, which means who and what has the access to the stored objects. So, fine grained control uses GCP IAM policy to determine who has access to a specific resource. In uniform access control, we won't be able to set access per object later on. So this I explained you this part. So now choose the security options and create. So we will choose the security options and create. This is how the storage bucket dashboard will look like. Now we can also upload files and folders from dashboards. So here from dashboard also we can upload files and folders. We will be built for your new file storage bucket based on usage. The more we use it and more we will pay each month. So it is based on how much we are using, we need to pay. So more we use it, more we need to pay. Uh, so this is I explained you how to create that also. Okay. So let's delete this since tags are there. Okay. Tags provide a way to conditionally allow or deny policy based on whether the resource has a specific tags. You can use tag and conditional enforcement policy for fine-grained control across your resource hierarchy. Okay, so if we have tag on the base of tag, we can access the control. So delete it. So just you need to mention delete and then click on delete. So it is mentioned like it is the soft delete policy. Okay, so this bucket is deleted now. Uh, let's proceed further. Uh, Deployment methods on GCP. So what are the deployment methods on GCP? So these are all the deployment methods on GCP. We have compute engine, then Kubernetes engine, app engine, and cloud functions. So here we have managed infrastructure, and here we are like dynamic infrastructure. Here infrastructure will be managed by Google itself. So so compute engine comes under infrastructure as a service. This is hybrid and this is serverless logic and this is PaaS. Okay, PaaS is like product as a service. So first let's talk about Google Compute Engine. Compute Engine is an infrastructure as a service product offering flexible, self-managed virtual machines hosted on Google's infrastructure. So what this is offering? It is offering flexible and self-managed virtual machines which are hosted on Google's infrastructure. Compute engine includes Linux, Windows based virtual machines. So these virtual machines may be based on Linux or Windows. Local and durable storage options. Okay, so and a simple REST-based API for configuration and control. So now, while implementing Google Compute Engine, an individual would have the opportunity for making uh, virtual machines, locating CPU and a memory. So we can decide how much CPU we want and how much memory we want. A piece of storage such as SSD or HDD, along with quality and quantity of storage. So we can decide what should be the quantity, means how much we require, and what should be the quality. We will create one virtual machine also. I will show you. Add GCE, Google Compute Engine. One can pick Abacus cases that could be of variable range. In terms of storage, even customized virtual machines can build according to workloads. Okay. Now, virtual machine is layman's language, can be understood as a digital version of the physical computer. So this is just a digital version of physical computer. Means there is one computer which is not uh, put on your desk, and you it is like digital version. You can access from your computer itself. It is virtualized instance of a computer that can perform almost all the functions as a part of the computer. Okay, so whatever the functions your computer is performing, and this can perform all those functions. Each virtual machine consists of a complete operating system. So each virtual machine is consists of a complete or operating system and a set of virtualized hardware resources. So this virtual machine which we will create has its own operating system and virtualized hardware resources, including CPU, memory, storage, and network interfaces. The operating system running inside the virtual machine is isolated from the host operating system. So the operating system which will be running from your in your virtual machines is isolated from the host operating system and other virtual machines running on the same physical machine. Means which physical machine which is running inside Google infrastructure. Okay, so if you have taken one virtual machine which is created, so your the operating system which is running on your virtual machine will not be the part of other virtual machines of GPU who is running in that infrastructure. Virtual machines run on a physical machine and access computing resources from the software. So these virtual machines run on physical machines in Google facilities and access computing resources for the software, which is known as hypervisor. Okay, so name of the software is hypervisor. Google Compute Engine is Google's infrastructure as a service virtual machine offering. It allows customers to use virtual machines in the cloud as server resources instead of acquiring and managing server hardware. So, it is like a infrastructure as a service. We don't need to manage any infrastructure. Google is providing infrastructure as a service. It allows customer to use virtual machines in the it allows customer to use virtual machines in the cloud as server resources instead of acquiring and managing server hardware. So we don't need to manage any hardware of server. Okay. So this is the diagram. Here we have virtual machine app and OS is provided to us. There is virtual hardware which is provided for each machine like CPU, input output, IO, RAM and disk for this, and there is a software named hypervisor. So this is the physical hardware which is there on Google infrastructure. Google Kubernetes engine. Now we will see the Google Kubernetes engine. Kubernetes, also known as KTS, is an open source system for automating deployment. Okay, just a second. Okay, so Kubernetes, also known as KTS, is an open source system for automating deployment, scaling, and management of containerized applications. So, this is used for automating deployment and scaling and management of containerized applications like Docker. Kubernetes is a portable, extensible, and open source platform for managing containerized workloads and services that facilitates both declarative and configuration and automation. So, Kubernetes is a portable, extensible, and open source platform for managing containerized workloads. So, it is used to manage containerized workload and services that facilitates both declarative configuration and automation. Containers are similar to virtual machines. So the containers like Docker images, uh, Docker containers are similar to virtual machines, but there is some difference. But they have relaxed isolation properties to share the operating system. So they have some relaxed isolation properties, and what are there? What are that? That is, they share the operating system among the applications. Therefore, containers are considered lightweight. In virtual machine, OS is not shared. Okay, each virtual machine has its own OS operating system. But in containers, uh, operating system is shared among the applications. Therefore, containers are considered lightweight. Similar to virtual machine, a container has its own file system, share of CPU, memory, process space, and more. So, similar to virtual machine, a container has its own file system, share of CPU, memory, and process space, and more. So, why you need Kubernetes and what it can do? So, why we need Kubernetes basically? Orchestrate containers across multiple hosts. Okay, make better use of hardware to maximize resources need to run your enterprise apps. This make better use of hardware to maximize resources need to run your enterprise apps, control and automate application deployments and updates. So it control and automate the application deployments and updates. Mount and add storage to run stateful apps. So it provide and add storage to run stateful apps. Scale containerized applications and their resources on the fly. So it scale containerized applications. Declaratively managed services, which guarantees the declarative managed services, which guarantees the deployed applications all are always running the way you intended them to run. Health check and self heal your apps with auto placement. It is used for health check and self heal your apps with auto placement, auto restart, auto replication, and auto scaling. Okay. Now Google App Engine. So what is Google App Engine? A Google App Engine is a service for developing and hosting web applications in Google's data centers, belonging to the platform as a service category of cloud computing. So this Google App Engine belongs to the platform as a service category of cloud computing. Guys, just take a 2 minutes break, then I will continue. Hello. So, guys, let's continue. We are talking about Google App Engine. So, Google App Engine is a service for developing and hosting web applications in Google's data center. So, if we want to develop and host web applications in Google's data centers, we use Google App Engine, belonging to the platform as a service. So, it is basically belongs to platform as a service category of cloud computing. Web applications hosted on hosted on GAE are sandboxed and run across multiple uh, servers for redundancy. Okay, so web applications that are hosted on Google App Engines are sandboxed and run across multiple servers for redundancy and allowing for scaling of resources according to the uh, traffic requirements of the moment. App Engine automatically allocates additional resources to the servers to accommodate increased load. Okay, so if a load is increasing on the server, so App Engine automatically allocates additional resources. Service provided by App Engine includes platform as a service to build and deploy scalable applications, hosting facility in full managed data centers, uh, a fully managed flexible environment platform for managing application, server and infrastructure. Okay, so these are the things. What are the advantages of GAE? Google App Engine allows you to build web applications on the same stable and extensible platform which has support facility of Google's large number of applications. Google App Engine give Google App Engine gives facility to use and run applications in Google data centers. Google App Engine's language, Java and Python are easy to understand and implement. This platform is absolutely free. You can purchase additional resources if needed. Using Google account, you can use Google App Engine services. So by using the Google account, you can use Google App Engine services. It is easy to scale up as your data storage and traffic needs grow with time. So if your needs are growing with time, you can scale up also. Okay. User can easily write the application code and test it on their own local system. So user can easily write application code and test it on their own local system and upload it to Google at the click of a button or with few lines of command. So you can do development in your local system, then you can easily uh, upload it on the Google. Google takes care of all the app maintenance that allows user developer to focus on the feature of the application. So Google basically takes care of all the apps maintenance. Okay, so you don't need to do any maintenance and allows user developers to focus on features of the application. Now come forth that is Google Cloud Function. With Cloud Function, there are no servers to provision, manage, patch, or update. Okay, functions automatically scale and are highly available and fault tolerant. So functions are can automatically scale and these are highly available and fault tolerant. Cloud functions are great for building serverless backends. So they are like cloud functions are basically great for building serverless backends, doing real-time data processing and creating intelligent apps. A function is an independent unit of deployment uh, as a microservice. It merely codes deployed in the cloud that is most often written to perform a single job. Like if we are want to, they are generally written to do a single jobs, like saving a user to the database or processing a file in a database, performing a scheduled task. So like this, for these small functions, we create a function. 90 plus new event track sources. So Firebase, BigQuery, Cloud SQL, these are the parts of Google Compute Function Gen 2. Compute Engine, IAM audit logs. Which method should we choose? Now comes the important question, which method should we choose? What level of abstraction you need, means what level of support you need and what level you want to do by yourself. If you need more control over the underlying infrastructure, for example, the operating system, disk images, CPU, RAM, and disk, then it makes sense to use compute engine. You can create virtual machines and use them. If your applications are containerized, you can use Google Kubernetes engine, which gives you full control over the container down to the nodes with specific OS, CPU, GPU, disk, memory, and networking. Google Kubernetes Engine also offers autopilot when you need the flexible and control but have limited ops and engineering support. Use App Engine if you just want to code up your HTTP based applications. So if you just want to code your HTTP based applications, then use App Engine. Okay. And leave the scalability and deployment of app to the Google Cloud. Then, if your code is a function and just perform an action based on the event triggers, then deploy it with cloud functions. Makes sense. What is your use case? You have to decide by yourself, means what is your use case, then you need to decide. Use compute engine if you are migrating a legacy application with specific licensing. If like you are migrating a legacy application with specific licensing, OS, kernel, and networking requirements, then you should use compute engine. Like Windows-based application, genomics processing, etc. Use Google Kubernetes engine if your applications need a specific OS or networking protocol beyond HTTPS. When you use Google Kubernetes engine, you are using Kubernetes, which make it easy to deploy and expand into hybrid and multimodal environment. Use App Engine if you want to deploy and host a web application. Okay, so if you want to deploy and host a web application, use Web Engine. So App Engine. Examples are web applications, mobile app backends. Use cloud functions if your code is a function and just uh, perform an action on an event trigger from PubSub or cloud storage. Example, kick off a video transcoding function as soon as video is saved in your cloud storage bucket. So then we can use that function in cloud function. What are your team dynamics like? If you have a small team of developers, then you want their attention focused on the code. Then a serverless option, App Engine, is a good choice because you won't have a team to have a team managing infrastructure, scale, and operations. If you have bigger team along with your tools and processes, then Compute Engine or Google Kubernetes Engine makes more sense because it enables you to define your process for CI/CD, security, scale, and operations. What type of mm, billing model do you prefer? Compute engines and Google Kubernetes engine billing models are based on resources. So they are on the basis of resources. Like you have defined this is my compute engine and this much CPU or GPU I required. So then you are billed for that, which means you pay for instances you have provisioned, independent of usage. Either you will use it or not. That that doesn't make too much sense. App engine and cloud functions are billed per request, which means you pay as you go. So as much request you do, that much you have to pay. Now we will uh, create one compute instance here, and then uh, okay. So now we will create one compute uh, one instance also. So just a second. Okay. So next part for this we will create in